Everybody. Today is February 8th. We are here to talk about Parkinson's disease phenotype. Dr. Wu is leading us through this clinical idea as part of Phenotype February. He made a fantastic post last year in Phenotype February 2022. This year, the goal is to get the phenotype to completion as defined as in the phenotype library of Odyssey. This requires a certain things to be done. As part of this work, this is the second meeting on this conversation. So Dr. Wu has made significant progress in this phenotype. So if we would start out just to catch up this group in 5 minutes, the previous conversation and the work that you've done so far, so that we can go deeper after.
Yeah. Did you want me to step in at this point, Gowtham, and just bring people up to speed?
That's right. Absolutely.
Okay. Yeah. So I can share my screen if that's okay.
Yes.
I will eventually post this as an update from last year, but this is the document from last year. Much of it is unchanged as the literature review and the definition of our problem. And we're going to focus on Parkinson's disease, but as you'll note that we do have this high interest in the related neurodegenerative Parkinsonism syndromes, but we are going to focus on Parkinson's disease to take a phenotype to completion and use that as a jumping off point where we can also dive into the other types of phenotypes. If we skip down to the bottom, and I'm not going to go into all of this, and some of you may have read my posts before, this was the focus. So our decision was for our P8 strategy to focus on two phenotypes, one or two, and we chose two. These are published phenotypes in the literature. They are limited by, so the paper, Zumpsky and Chang, 2019, used a data set from the VA, and the gold standard was a chart review of 450 some cases, and was the most thoughtful type of a phenotype that we identified in our literature review that was really crying out for a network-wide application. The challenge is that the top accuracy combination of PPVs and sensitivity, specificity, the highest one was what they called the tiered consensus algorithm, which is recommended, but is limited by needing specialty information. But I think it would be the opportunity to run this at a network level and just quantify how variable and what the maybe limitations of the OMOP model are for capturing specialty and how important is it. There is an alternate model called the Unanimity algorithm, also in the same paper, with a slightly lower accuracy, and this is not dependent on specialty information present. So I have completed this in Atlas. And those are the focuses. They also reported in this paper the addition of medications in both of them. So those are easy to add. And so I included them as a 1.3 and 1.4. Those will be the focus for P8. I don't think we need to go into other details. We do have an X spec and X sensitivity kind of idea so that we can run Phi evaluator. I'll pause there for any questions before I dive into the details of the algorithms. Okay, hearing none, I'm going to dive into the details. So I'll start with the unanimity one, which is easier. So the unanimity one, 2009. So the initial event cohort, and this was adapted from Ryan's implementation from last year. I have redone the concept sets so that I think they are more reflective and more accurate to what we want. So the initial event cohort is people having a pretty broad, and it's actually not even neurodegenerative Parkinson, it's now just Parkinsonism condition. So it's pretty broad, finding the earliest occurrence. Inclusion 1 is adult onset. 10% are under the age of 40 for Parkinson's disease. And then we have inclusion criteria 2 and 3, which count at least one occurrence of the specific PD condition occurrence, and then having 2. And I broke this out so we can do some cohort analysis. And the event, this is not in the paper specifically, but we added a 30-day difference in time between the two. And the fourth inclusion is basically you don't have a competing condition code. And there are two concept sets here. One is the neurodegenerative non-PD Parkinson's, because Parkinson's is neurodegenerative. I've already created that concept set, and the condition codes related to secondary Parkinsonisms, and I have created that set as well. And that's it. And you can always add the criteria of a medication if you wish, and we have that concept set. So any questions about this one? Should we go to?
Yeah, so specifically about the medications, do you want to take the approach of having two flavors of the same idea, one with the medication and one without, or do you want to?
Yeah, I would do both. It's pretty
Okay.
easy, pretty free. I've created both here. Are you guys seeing my screen still?
Yes.
So this is the Atlas demo site. So there, I'll just pick this one because it's just the medications have an added criterion. So I have a broadly inclusive concept set that's been defined. How do you? Yeah, you can sort of see it here, and this is per how Ryan did it last year, earliest event. And then here's our criteria: age, one code. I hopefully did this correctly. Event starts 0 days before for the first one. Then the second one is this particular code. At least one of them has to be 30 days after the index start date. That may be a problem because the index start date is defined as here, and it might be a not the PD concept code. Or this index date refers to this nested one, so it actually works. Yeah,
it's a nested one.
Yeah, so this one works. Yeah, it's this PD code followed by another one 30 days after the index code referencing the outer box. Okay, so we did that correctly, I think. And then has no secondary Parkinson, so 0 occurrences of secondary Parkinson's concept set. And I don't know if I have to set this as 0 days before as well.
If you don't want, yeah, so if you do it that way, 0 days before and all days after, you're limiting to the period in the future. So if somebody had secondary Parkinson's before the index date, they would still be in.
Yeah, but all of these codes are included within the broadly inclusive set.
Perfect.
So it will be okay. Thought about that.
No, actually, can we go back here? So how are you thinking secondary Parkinson? What is the law? Are you trying to say you cannot have secondary Parkinsonism on that day, or you cannot have secondary Parkinsonism anytime in your life?
Anytime in your life, right?
Okay,
that's the unanimity algorithm. Is we want purely captured PD, and there's no competing codes.
Okay, so let's do that all day before, not 0.
But it wouldn't make any difference, Asa, because the entry event criteria is a superset of this rule.
Correct.
Oh, so you won't have okay. Unless you have different observation periods in the data. So you can do all, and then check that box of use all observation period if you go down.
Yeah, so I suggest Asa that
you want him to walk through it and then
let's walk through it and then do fine tuning later.
Okay, fine.
So that's up to. I mean, I'm okay with all as well. It because the algorithm, this particular one, will exclude all of these conditions, and these are the non-PD neurodegenerative conditions. Is there? How do I? Oops. Okay, so now you can see. So these are very specific neurodegenerative conditions, and I removed the infantile one. That was a child of this this one that is the adult neurodegenerative one. So I checked all these. I have to go back here. Okay, and then there's a PD medication. I have a curated list here of the medications. There, now I can show you. And that's it. That is the unanimity algorithm that got published with a little bit of interpretation and ready to go, minus some other corrections.
Perfect. So for the unanimity definition, first of all, Dr. Wu, this is tremendous progress. You've made so much progress in the past 2 days and compared to the conversation we had on Monday. So thank you for doing that. And this allows us to focus and say, we'll give you feedback on the fine tuning. You got the big picture already correct. You got the main definition correct. So in terms of the next steps for this particular unanimity definition, because this is on the atlasdemo.odyssey.org and it is kind of not secured, I think the first step should be to copy it over to atlasphenotype.odyssey.org, which is secured, and I can take that and do it right now. That one comes with a little bit of extra insight in terms of concept prevalence count, so you can actually look at those concept prevalence and make some decisions of refining if you want to, and we can spend some time fine tuning, like the ideas that Aza proposed. We could do that. So that's one option. But I would like to take the immediate action to move this cohort definition to Atlas Phenotype, just because anybody in the community can now delete it, and that I don't want that to happen by intentionally or unintentionally.
Right. Okay. Yeah, these are, I think, ready to go. This is the version that does not have the medication criteria. So I think it's all set. Okay. So should I go on to the complicated one?
Yeah, so let me,
okay.
What was the ID number and Atlas demo?
Yeah,
of the first one,
it's,
the Unanimity.
Yeah, it's the core one is 1781748.
Okay, so I'm copying that over. And let me share my screen so it's just, no.
Yep. And do you want the other one with medications?
Yeah, so let me set up my computer first to make it possible.
Why don't I
think you can continue the other one. I'll track.
Yeah. So let's talk about the other one. So the other one, here, let me, yeah, I'll just walk through it. All right. So I'm going to skip this one for now. Okay. So it starts out with, so the idea of the tiered consensus algorithm is the idea that the people that are most capable of making the diagnoses and distinguishing neurodegenerative Parkinsonism syndromes separate from Parkinson's disease are movement disorders experts as the top tier, and then neurologists as the second tier, and then everybody else. And so the algorithm is designed to put more weight on the top tier specialties. And it does a second thing. The second thing the tiered consensus algorithm does is it reflects the fact that a lot of the neurodegenerative Parkinsonisms and Parkinson's disease, the diagnosis only becomes clear many years later. And so if you do the unanimity algorithm, you run the risk of excluding cases of Parkinson's disease if somebody was overexuberant and calling it neurodegenerative Parkinsonism early on, because they wanted to be broadly speaking, oh, this is a neurodegenerative Parkinsonism, but then later on, and it's coded in that way, but later on they become Parkinson's disease and it's very clear. We needed a way to handle those. Any questions about the general idea? So initial event cohorts are all the same, at least 2 occurrences of the Parkinson specific code. And then we go into the specialty criteria logic. Okay, let me skip to what I wrote in words first, and then we'll go into how OMOP might do this. So this is challenging. So the first is, we would like to, okay, so there's 2, I already talked about this, movement disorders and neurology. So the criteria are, if the person has at least 1 visit with a movement disorders person, only look at those visits, identify the condition codes at those visits, and if the PD specific condition code is the most frequent one compared to the condition codes of the non-PD ones, then the criteria is met and you stop. And let me just blast through this, because I understand that these are philosophical differences in how OMOP is designed in some way. But then if there is no movement disorder person involved, then you do the same. Is there one visit with neurology? And then you do the same comparison. PD condition code is the most frequent compared to the non-PD Parkinsonism, then you meet this criteria. And if there's no neurologist involved, then you do the same analysis for that subset of visits as well. I will add one other thing here, is that the paper used a 3-year look back time, which is also important to realize, because if people have Parkinson's for, say, 5 years, you can safely ignore the first 2 years for purposes of applying this aligned with the published phenotype. All right, so I'll stop here and see if anyone has any questions.
Yes, could you elaborate the most frequent rule here? In other words, is it at the subject or the patient or the person level, or are we talking about the provider level? The provider more frequently codes Parkinson's disease versus non-Parkinson's disease, non-PD Parkinsonism, or is it the patient got more codes?
Yeah, it's patient person oriented, because the patient may see multiple movement disorders people or multiple neurologists, and they will disagree on the diagnosis. And this was the attempt to find the consensus among each tier of specialty. So if they saw movement disorder people and they over time have coded different parts of Parkinsonism, they're trying to ascertain when or which one seems predominant.
Yeah,
but only in those visits by that tier of specialty, ignoring neurologists. But if you don't have a movement disorder person, which is an issue, then in finding those visits, then we just go to neurology.
Yeah. So this is a complex logic. I do not think Atlas can support it as designed, but I know there is a comment on the post here, on the chat here. Fabricio, do you want to quickly talk about FIA?
Sure. So FIA is this R package that is a SQL query builder. And at the end of the day, what it lets you is build a SQL query that encodes the logic you described. For example, the logic of computing, for example, the percentage of the encounters that are from a movement disorders professional that have the primary diagnosis for Parkinson's disease. And then you can compute that number, and then you can use that number in the logic of the query, which is a kind of calculation that Atlas won't be able to do. Now, again, it's just a SQL query builder. So at the end of the day, what I'm saying is it is possible to do that in SQL, right? Which is not news. Yeah. And the real point is that we do need the Odyssey infrastructure if you're going to do a network study. So this was just to comment on the implementation, but not on how we can do this within the context of the network study.
Yeah,
got it. That makes sense. What is that tool called?
It's an R package that I wrote called PHEA, PHEA. It's on GitHub. Got it. I invite everyone, of course, to get to know about it.
Okay. I see other hands up. I do have a solution in Atlas, but let's keep going with the questions at this point.
Mm-hmm. Evan, you have your hand raised.
First, just to signpost, I would really like to see, and this might be a model for it, an implementation with FIA that does some of this summation across codes, because I actually think, even in doing case reviews, profile reviews, that becomes one, typically one of the decisional features, really, like what, especially when you're looking at competing diagnoses, the weight of the record starts to sway typically towards the ones that seem to kind of keep coming up more often, temporally kind of make sense, and things tend to kind of gravitate towards that competing diagnosis being the most probable state of the patient. And so I just to throw it out there, I think this would be potentially would be one use case, but the broader number of applications could be quite broad. And very useful. And I guess that the second question was, and maybe you you guys know this offhand. I don't know, like provider type, how well captured is that in our network data sources? Because I actually don't know. I've never seen us use it, and that makes me think that I don't think we actually have a great great way of capturing it.
Yeah. So before anybody answers the question, as moderator comment, just to make progress, I want to table the conversation on FIA. Apologies, Fabricio, but we will get to FIA. But I provide a specialties in scope. I want to make sure that we get to the focus of Parkinson's disease.
Right. My Teams is very inconsistent. So I was trying not to share, and now I'm trying to share again, and I cannot. I'm like clicking the share button repeatedly.
Yeah. So I'll try to answer your question, Evan, as Dr. Wu is figuring out the technical issues. So provider specialty is a challenge for many reasons, including the lack of standardization of the vocabulary for provider specialty. The other thing is, what is a provider itself is an ambiguous idea inside an Odyssey, because is it a representation of the care, or is it a representation of the board certification of the physician? And it is possible that a person who's board certified in internal medicine would provide a nephrology specialized care in a nephrology clinic. And so those are constructs that has not been solved yet. So in this particular case, it is possible for an internal medicine trained physician to manage Parkinson's disease in a Parkinson's disease clinic.
Yeah. So so I started to do this in Atlas, and let me see, where was it? So Patrick had posted this last year. And so leveraging visit and linking to provider specialty, which is probably going to be variable. And I think there is some value in just seeing how well people are using this in their OMOP instances. And there could be some, like, for example, we have access to our own data set. We don't have Atlas up and running yet in our local set, but I can curate something in Atlas where I could say visits in this location are known to be movement disorders. And then we would implement that as an option and just say, you know, if you adopt trying to do this in a network for our Parkinson's cohort and you're doing the tiered thing, consider if you have a location-based specialty that would make sense for movement disorders. But if we cannot, then we cannot. Let me walk through the logic. I made the assumption, and what Patrick did here was to use the NUCC logic, and I actually did that in Atlas demo. Movement disorders, by the way, is simply not represented in any current coding system other than SNOMED, which has everything. Because it's not an ACGME approved subspecialty. So I basically, as a movement disorder neurologist, I did an apprenticeship fellowship. So yeah, everyone just kind of knows each other, and you say, oh, I did my fellowship there, and I could be George Santos, and you would never be able to super verify it. But anyway. Okay, so this is what I came up with. This is revised from this morning. This is at 9 a.m. local time. So the way I thought about doing it, and you guys can poke holes in it, it would be great. You would start with, are there visits with a neurology specialty as defined by visit specialty linked to the provider during the whole observation period, which is specific to each person, I believe, but you correct me if I'm wrong. If the answer is no, they have never had a neurology specialty coded within OMOP, then you go over here and you say, is there a Parkinson's condition specifically in the last year of the observation period? And if the answer is no, the criteria are not met, actually I might revise this to be further, but if the answer is yes, there is a Parkinson condition in the last year of the observation for this person, then are there any exclusions, the same exclusions we previously applied, in that last year? If the answer is no, then you've met your criteria. If the answer is yes, then you're rejecting that one. The complication occurs over, and it may apply here, is that you basically do this, and I mentioned the 3-year look back. So basically, if you did see a neurologist sometime during the entire observation period, which would include movement disorder people, then you say, did the Parkinson condition come up in the last year? If the answer is yes, then you go through the same logic and you say, are there any exclusions? No, in the last year, then it counts, and yes, then it doesn't count. And I make some notes saying we're allowing for these other diagnoses to be made in earlier years. If the answer is no, then you go into this cascade, right? This is the same. This is in the last year. If the answer is no, then you check, for the neurologist specialty. Remember, this is all neurology now. Between 1 and 2 years prior to the end of the observation period, and you check for exclusions at that point. And there's no Parkinson condition in the last 2 years. We'll do the look. We'll complete the look as published. We'll do a 3-year look back, check 1 more year, and then see if we can fulfill criteria or not. And that is sort of what I came up with as an operationalization of this within the tools that I found available. That seemed somewhat feasible.
So we can dissect this. So first of all, this is a very innovative proposal. This is great. Second is we need to think about any fallacies, errors in this logic, right? And that's one frame thinking. And the second is I think I will need a little bit more time to see if it is serving the intent that you're trying to do, which I mean you're saying it does. It serves the intent, so it might be. Just have to think this through. And the last and the final point is, does it make any difference?
Right, we don't know. We actually don't know if it makes any difference. And then as I go through the logic, this is very complex. I have to think through the logic, make sure I don't have any holes in it as well. But as I look at it, as I present it, I'm like, this little box over here, this probably requires the 3-year look back as well, right? So I have to think about this again and revise this again. But yeah, I'm interested in hearing you all think about the logic, but the logic is more on me and my team, and the technical feasibility is more for all your expertise here.
Yeah. Fabricio.
All right, thanks very much. That's an impressive phenotype. I'm wondering, maybe you've mentioned this and I didn't catch. This phenotype, this tiered criteria, was it developed with phenotyping in mind or with manual chart review in mind?
It was done with manual chart review. It's this paper here.
Okay, great.
Yeah. Gowtham, did you link us to the paper? I know it's in the post, I think, but did you put it in the chat? If you can put it on.
Yeah, some of this content was emailed to me by Dr. Wu, and we will.
This is a PDF, we'll try to so I don't have the link right now, but yeah.
Okay,
this is the
don't
paper.
worry, I found it.
Mm-hmm.
Yeah, and so the definition, and we know the authors. We can always ask further, but it's not a extensive phenotype, right? This is exactly what the OMOP team is trying to do. Is you write all this paragraph text, and you're like, how do you actually implement this, right? Oh no, sorry, that's the results. The description is even shorter.
One thing that concerned me about the logic was because the presence of a single neural visit completely switches the patient to the other side, where everything must come from a neural visit. So if there's a code that means a neural visit and we are not capturing that code in some site, or if the neural diagnoses were coming from non-neural visits, but they are still valid, we're going to miss all of those because of the presence of a single visit with a single neural visit makes the patient switch to the other side.
Yeah, I think that's right. I think what we need to do is at the top node, limit the search to the last 3 years. for the observation period. Because that's what this paper did, right? This is a 3-year look back. So within the last 3 years available, was there a neurology visit?
I see.
Yeah, and from a practical
it
standpoint,
still sounds strict. I'm sorry. It still sounds strict, and just like the presence of any code for the competing diagnosis, because on one hand we have all these criteria for establishing our diagnosis, for meeting our criteria, but just the mere presence of a single code of a competing diagnosis completely eliminates that patient. But the presence of a single code doesn't necessarily mean that the patient has a condition. So we might be being a bit strict there. So
Yeah.
in those two points, I think the logic. And this might also lead to results that look confusing, because on one side we considered all diagnoses, on the other side we only consider diagnoses coming from neural visits.
Well, I think the unanimity algorithm is even more strict, right? So the unanimity algorithm was a recognition that, yeah, it might be hard to figure out who's a movement specialist. So it excludes, if you have one code, and maybe what we need to do, Gowtham, is the unanimity algorithm needs to be tweaked actually to reflect the 3-year look back, because the way it was done here is a 3-year look back as well. That's all the data they had available to them to develop this algorithm. So in fact, the unanimity algorithm should be a look back for 3 years, so that if you have a competing code earlier than 3 years, that's actually okay, and it's not as strict.
and so you can, as part of the question that we're trying to answer, we can test both of those flavors, one with 3 years look back and one with all observation, and see if there is empirically any difference across a network of data sources.
I think that would be great to do, yes.
So that could be one of the objectives of this work. You could say, does it really matter 3 years versus all period?
Right.
And from my experience, most data sources do not have 3 years on most of the people.
So Gautam, this actually, it matters. It depends on how you're thinking of the 3 years. If you're thinking of it that if it's a time period of time that you are applying exclusions, so meaning that you are you are excluded if you met any of these things in a 3 years period, but it's okay if you had them before that. You can go, that's actually fine. You can just add that time period on your exclusions only there. The problem is, as you just said, most people don't have 3 years of look back, and only because you don't have any of the exclusions, you have to think of a person who doesn't have 3 years and also doesn't meet any of the exclusion. Would you still trust that case? The reason it didn't meet any of the exclusion is purely because it just met that entry criteria. And so, like, you have to think, are you only looking among people who you found and at the time they met the entry criteria has 3 years of look back? And so you're able to do that digging into their history to make sure that they are real cases. Or you're thinking, no, I'm taking everybody, and if they happen to have 3 years, I'm just going to make sure that they don't meet any of those exclusion criteria. Because that's going to shift, like that's going to affect your numbers a lot. Is the 3 years required to be, yeah.
From my point of view, again, I've highlighted in this paper, is they had a practical limitation of 3 years, right? They just weren't capable of doing more. So if we want to translate this to here, I think during that 3-year period, there are going to be people who only have one observation, right? That's just what's going to happen. And I would not exclude them. I think this is why the criteria in the algorithm, in the phenotype, is a minimum of 2 instances of the specific Parkinson's code. Okay. But they can have basically 30 days of observation and still get qualified and meet the phenotype, long as within the 30 days they did not have the competing code.
Perfect. then we should not really think at all of the 3 years period, like ignore it, because if you're not thinking of it, that it is one way of confirming that the person made the entry criteria and also doesn't have any of these exclusion in the past, because then you require that time. But if you're not thinking this way, then worry about that 3 years period. And for all purposes,
it does matter, because if you do have cases that have observation periods that are longer than 3 years, we do want to ignore things that were 4 and 5 years in the past.
Yeah, okay, so you can add this.
They can have exclusions 4 or 5 years in the past and still fit this algorithm here.
So that actually, the reason why we're saying it doesn't matter, because anytime you apply an exclusion criteria, it's explicit in Atlas that you have to define at which time frame you want that period to be applied. So you have to, like, anyways, that's the second, like, once you put the exclusion criteria, you're gonna put, is it all time? So in that case, you would put the 3 years prior instead of all time or 0 days.
Like
prior.
1,024 days. Yeah. Okay.
Yeah, so in this criteria, so this is the unanimity criteria. This requires the exclusions here to be applied. In fact, all of these should be applied within 3 years of the last. Can you clarify observation period? Is observation period specific to each person or for your entire data set? Okay, I thought it was per person. So how would I change, say this criteria has one code to be registered, right? So the entry criteria is earliest event. Now they're in the cohort. But we want a PD code within the last 3 years of the last observation of any of these.
Just simplify this. You will put 3 years in that time in the bottom instead of 0. Currently, you have 0 before, all after. So if basically this is something you want to apply on
1,095. This will be 2 years.
I figured you guys knew.
And then you see that this is a allow event from outside observation period. You would click.
Why would I click this?
Yes, because now, so the way the OMOP is built is it is ID observation time specific. So every person is one person across the OMOP within a certain observation period. So if somebody goes out of the system and come back to it, as long as they have that gap and they go over the gap that is allowed, they will be acknowledged as if they're a new person. It's going to be a new person because it's going to be the same ID but with a new observation period. When you click that, now you can apply this on the same person with a different observation period, because you want to go back to as much time as you can for that person.
So, right, I understand. So each person can have more than one observation period for this entry criteria.
Yep.
So then, did I do it correctly by saying before index end date?
Yeah, I don't think
this should be 0 or.
Yeah, this can be all, because you definitely don't. You want that visit to have happened before the fact that they had that diagnosis.
I think we're talking differently, because I want the most recent 3 years as my time frame of analysis. So I need this to be before the last observation of this person. Does that make sense?
You want to have the diagnosis of Parkinson's disease
most recently. So in all of our chart reviews, the emphasis is on, when you're reviewing the chart, look at the most recent neurology visits and the most recent diagnoses codes.
Okay, so your entry criteria is completely wrong. Not wrong, but if you really want to mimic, not wrong, I'm sorry.
That's what I thought.
No, it's not wrong. Hold on. you have to decide. So the logic is the logic from the paper. That's fine. But when you model it, you have to decide as a researcher, where are you standing in terms of time? Where are you standing? Where is your present moment? And then you can decide you're looking back or you're looking forward. So whenever you do chart reviews, you are technically, as you said, sitting on that last moment, and you're going back in the record. But when do you want, because that index date decides the time that the person going to be flagged in the data as having Parkinson's disease unanimity. So decide when do you want that date to be. Is it the time they meet your full criteria? Is it the time the last visit, or is it the first time they have that diagnosis, and then they can pull the criteria in the future? Like, when do you want that label to happen?
Yeah, I think for the phenotype, you would take advantage of all the data that's available, and you would sit at the last observation and look back. We have an intense interest, of course, at the earliest date, because the motivation for this whole work is because we're trying to model and advise on population-wide, statewide public health registries for Parkinsonism. So we're really interested in incidence, but for the purpose of phenotype, I think we're standing at the last visit that's available and going backward 3 years to apply this paper.
So
but
another way of
to.
framing so another way of framing this problem that is being solved is Dr. Wu is not worried about index date misspecification. He just wants to make sure that the definition has got good performance characteristics in sensitivity and specificity and those operating characteristics, but not worried about date. It's okay if the person was diagnosed 10 years ago, as long as we identify them. Would that be a fair translation, Dr. Wu? At least for this implementation.
I missed the last part of that, but yes, I'm mainly interested in just whether they. I missed the last part of that, Gowtham. Say that again.
Yeah. So to repeat, so we're thinking in two main categories. One at the person level, does the person have the phenotype or not? And then the second one is, when did the person start having the phenotype and when did the person stop having the phenotype? So this latter one, which is when did the person start having the phenotype and stop having the phenotype, is the index date misclassification construct. But whether the person has the phenotype or not is measured by the operating characteristics of sensitivity, specificity, positive predictive value, negative predictive value. If you want to think just on sensitivity, specificity, positive predictive value, negative predictive value, but do not care, and maybe there's a better choice of word, is not really bothered by index date misspecification at this time, then this approach sounds reasonable, where you will get the persons with the disease, but you won't get an accurate start date.
That's fine. Yeah, I think we need the population defined, and then we need to run further analyses on the data set that is available to find out algorithms that detect the start date. Okay. So yes, I care more about the sensitivity specificity as I started the presentation. Yeah, we're picking this algorithm because it's got some nice characteristics that we really would like to see if it applies elsewhere.
Okay.
So then the practical issue is, how do we define this so it's operationalized? I think it's latest date makes sense, right? Because we're not worried about earliest date anymore.
I actually don't think it matters. It's just, if you put last date, then now you're thinking of exactly like the paper. Now you're thinking of you find that last visit, that the last time the person has the Parkinsonism code, and now you're putting requirement on what should have happened before that. Versus,
I think that's correct.
Versus you can also operationalize it in a way. Let's pick the first time the person has Parkinsonism, and then we can add all the criteria to happen anytime in the future.
Yeah. So what I was saying is,
it's the same thing, but if you want to implement exactly the paper, then you'll take the last time and look back.
But yeah. So what Asa is saying is, take the unanimity algorithm and take a mirror image of it and implement the mirror image. So instead of going from back to forward, start from forward to backward, or
It makes sense to me to do what the paper does.
Yes.
Because I think what we want to do is have good characteristics to work off of, find the cohorts, and then we're going to do just a ton of different analyses on those cohorts and figure out, okay, when do they start, and what were the earliest symptoms, and all this other stuff that we want to do. Because I don't think the field of Parkinson's is ready for prospective real-time analyses yet. I think the first thing Azza said was right, that we do want to emphasize only the most recent stuff.
So it doesn't matter. All what you know that in OMOP, whenever you define a group of people, you also define with it, no matter what, you define with it a date. It doesn't matter if you care about that date or not. A characteristics that come with any cohort table, which like, think about if you apply this on a database, you're gonna end up with IDs. In OMOP, there is never an ID on it. There's always two columns. There's always an ID, actually three columns. An ID, a start date, and an end date. And all what happens is you can model as the way you want. All what happens is that start date, and once we apply this, will reflect the last time the person came with a Parkinson disease. That's what that start date means.
Right, that is the case. Yeah, that's
Okay.
the case. Right. So when you said we could choose start date as the earliest date, and then all the criteria go forward in future at any time, it is more challenging to define what the paper does, which is 3 years of look back time.
You actually can. It's just it's as Gowtham said, it's a gymnastic on your brain to do a mirror image. And
let's focus. I mean, we have 10 more minutes. In terms of making progress, this is fantastic. We can think about the same code definition, test it, and then decide at a later point to make an inverse of it. Right? It is possible, and let's not do it. Let's not worry about that right now. Let's solve. If you break it down, let's identify the right set of people, and once we identify the right set of people, let's think about index date correction later point. As of right now, in terms of the 9 minutes to make progress, we have 2 flavors of definitions implemented in 4 or 5 cohort definition. We need to have the action item of quality checks of Dr. Wu's implementation to make sure that somebody else has checked it and the intent of Dr. Wu has been translated without any small errors. That's one step. Second step is this needs to be converted into a OHDSI network compatible study package that can be executed. So those are the 2 additional action items we need. So Dr. Wu, specifically for you, do you think do you need more time to refine the definitions, or do you think do you need help to define the definitions? Do you need a partner?
Well, I think we want to just knock down the unanimity algorithm with the 3-year look back. So it's a revision of what you exported, right? So I'm doing it in real time right now. You guys are probably seeing what I'm struggling to do. And I think I'm kind of doing it correctly, but I would need a partner to make sure that I'm doing this correctly, right? But after I finish these last tweaks, I think it's ready to go. It makes more sense to me now. And then I need to come back to you with the logic of the tiered one, given your feedback. But I don't think we're ready for the tiered one. I think we can run the unanimity algorithm pretty quickly. Okay, I'm done. Can someone review this?
Yeah, Fabricio has his hands up, but before.
Yeah, please correct me if I'm wrong, but from what I understood, you were saying that from a clinical perspective, you are going to look at the chart and what is the diagnosis from the last encounter, right? So even if there was a competing diagnosis before, if in the last encounter that was Parkinson's disease, then you accept it and you don't exclude that patient.
3 years. You would look back 3 years and make sure there's no competing, because doctors don't code consistently and the patients are difficult to diagnose. So we look back 3 years, and the unanimity algorithm would exclude them if they have no competing diagnosis within 3 years.
Okay, I had thought you had mentioned that if the most recent diagnosis was Parkinson's, then you would accept that as Parkinson's. It's not as a secondary
No, that's the starting
Parkinson.
point. The starting point is you review the chart, you start with the most recent visit, you focus on neurology visits if they're available, and then you walk back through time, 1, 2, 3, 4, 5 years, looking for the sequence of events that occurred for that person to reach a diagnosis or an uncertain diagnosis of Parkinson's. That is how chart review works. So the fact that this paper did 3 years of available data and published their characteristics gives us at least a constraint and say, okay, 3 years is where we're going to exclude, at least for the unanimity algorithm. The tiered one, I think I will work on to make sure there's airtight logic further. But I would ask this group to act on, again, this is Atlas demo. Gowtham, if you could export this revision here. Now it's latest event and going back 3 years for almost all the criteria, 18 years old at the index date, which is now the last date. I think this is now good.
You will have to make it. Did you put 0? So it's basic. So criteria is always applied 3 years back up to 0, up to that day of the last instead of all.
Oh, wait, where am I?
So you see how you said the 100? Yeah. So starting with the second criteria.
Okay.
This one doesn't matter because age doesn't have a time attribute to it.
Yeah.
So here, you are requesting that one specific code to happen when event starts between 3 years before and 0 days before start.
Yes. Got it.
Now you're just looking at 3 years and you're including that day. So that means if somebody comes with these codes on that day is also excluded. And if so, same with this one. So everything will be framed as the 3 years before that day of the latest.
That makes perfect logical sense.
So you have to promote the same change, Dr. Wu, to that other flavor of unanimity definition that has medications.
Yeah. So I can save this one.
Yeah.
So hold on. We're not done yet. At the bottom, Gowtham, would he do earliest event or would he do latest event?
It wouldn't matter because I think the entry criteria is 1 record per person.
Oh, you're done. Correct. You can keep it, whatever. But then okay, that's right.
I can copy it. And I will say with meds revision 1. So this is after our talk. And I will add the criteria here as PD medications.
So I will build the study package, Dr. Wu, today, and I will post it. That will make it available for the Odyssey community to execute. That's then you can execute it on your system if it's ready, or whoever is volunteering. So it's up to, I'll do the introductions, but it is up to you to, beat the drum so that they are motivated to execute it on their systems.
Will this be just cohort diagnostics, or is it cohort diagnostics and evaluator, or is it just executing the cohort and getting numbers?
Yeah, go ahead, Dr. Wu.
We're interested in anything you guys will provide for us because, as Gowtham mentioned, I don't have an Atlas or OMOP data at my site yet. It's coming. So anything you guys can provide, cohort diagnostics, that is not individual level, I'd be happy to help review.
I'll throw a suggestion to just do cohort diagnostics, just given I know we struggle to run evaluator still, so that might at least get us something on a network level, and then sites that can do evaluator, maybe that can be a subsequent step.
Yeah, we can try to do the Phi evaluator?
Well, the Phi
J
evaluator
and J.
requires a X spec and X sensitivity. So I have not quite defined those fully. We have a very specific X spec that we would like to run. It's in the document, but we haven't had time. We're not going to have time to talk about it.
Yeah, that's right. So I would ask that you send me an email, Dr. Wu, once you've finalized the definition. I know you're already finalized. You just send me an email with those two links, 48 and 60, I believe. And then I will import it into Atlas Phenotype. I already did. I just have to overwrite what was written earlier today. And then I'll create the package, and then we'll call for the actions of the community, and whoever runs it will be your collaborator.
Are there any need to look at the codes? Dr. Will you feel good about the codes, or do you want us to run Phoebe or?
I think if you guys would like to run whatever diagnostics you can, that would be great. I know the cohort definitions were copied from Ryan's old version last year, so there's a whole bunch of old concept sets that are not used currently. All the ones I use are marked with Phi value Feb 2023. Those are mine. The other ones are old and can be removed. The other ones are old and not used.
Okay, so if you guys are interested, I have another 15 minutes of time that I could help. What in that 15 minutes, what we can do is take the definition from Atlas demo, put it in Atlas Phenotype, which is the next version, clean up, and then save, finalize, create the study package, and initiate network study.
Okay, I have probably another 15 minutes. What I'll do, Gowtham, is I will let me review and clean up the two unanimity definitions, and then send an email, because I'm on this computer right now. And once you receive that, they're ready to migrate, and for you all to check the logic.
Okay, so I'll wait for your email then, and we'll do an independent task, and of Aza and I, if you don't mind, we'll do a little bit of cleanup, just editorial cleanup, not logic changes.
Yeah, if there's a way to remove these other concept sets that are not
used.
So
if you go to that messages tab, which has the 16 number to it, and you can just say fix it, and you're done.
What do you mean by not used? Are they wrong, or you think they're not used in the current?
They were created by Ryan last year as individual concepts, but didn't really go through all the hierarchies that I did.
Okay, so you subsume. You include them already in your hierarchy.
I created new ones, yes.
Got it.
Yeah,
okay.
They're all labeled Feb 2023.
Got it, but Gowtham just fixed it for you. Yeah, they would disappear.
So if you click on the messages and just click through all the fixes.
Doing it. Yeah. Okay.
That's your
all right. Let me clean this up, and I'll send you all an email. Thank you, everyone, for giving me your feedback. It's been really great to interact with you all.
It might be worth, Alan, going through and the new version of Atlas, the phenotype version. Does it have Phoebe?
Yes.
Like the recommender?
Yes.
That might be worth it. I found that to be like enormously useful in building out concept sets. So that might be worth us taking Alan through. I'm not sure when that would happen, but
that sounds good.
Yeah, I'm happy to stay for 10 more minutes on the call.
To contact for that. I think it was you and somebody else who brought that up. Fabry or something?
No. Misunderstanding. So let me show you let me share my screen. So this Atlas is the Atlas Phenotype.odyssey.org. It's basically a more recent version with a little bit of extra stuff. So if I click on your Parkinsonism concept set expression, it has a new tab called recommended. This recommended tab will tell you, based on certain logic, concepts that you may have missed, and this is what Evan is talking about. So it says, given that you have said these 68 codes, what do you think about these things? So you just look at them and say, does these codes lexically or semantically match your intent?
I went over these. Yeah, I already did.
You went over but no, because you didn't have access to the recommender.
I think I did. When when I was creating concept sets, I saw a recommend button and I clicked it.
It is an Atlas demo. Yay.
Oh, is it? Oh, okay, good.
Yeah,
but it's quite helpful to go through the different, like I filter by relationship. I find that pretty useful. So like patient context, I think is a co-occurrence one. And you know, then the lexical and ontology matches. But yeah, if you've gone through it, then great.
Yeah, I didn't go through it in detail. I had already mapped this out with standard concepts before, so I was sort of familiar with what was there for my domain. So but yeah, you guys are expert, but I've been thinking about this for years.
No,
we'll come to the middle and figure it out. But I actually I did a lot of the parent and child relationships for everything, and yeah. So I think it's good.
So once you're done, Aza and I, before we publish it into the OHDSI network study, we'll just do some editorial cleanup. Editorial cleanup basically means, you know, spaces, capitalizations, spelling mistakes, if there is any. And I'm pretty sure we'll catch nothing. But once that is done, we'll push it as an R package. But the ask for you, Dr. Wu, is to create a post on the OHDSI forum so that we have a thread to say, thank you, Dr. Wu. Here is this network study package. And then we'll call on the community to execute.
Perfect. Thank you.
Gowtham, one more thing, since we have Dr. Wu here, can you click on the included no, we lost the screen. Because he mentioned that he used NOMID, we will be able to look at that in cohort diagnostics. But if you pick up the basic entry criteria, Parkinson, the main entry criteria, and Dr. Wu, did you look at the included concept tab just to make sure that you're not source codes, but I was even thinking Gowtham in terms of NOMID because he used the hierarchy.
Yeah,
and just filter on RC, not DRC, RC.
This is doesn't have records. This is the Atlas demo.
Won't even be able to do that. Okay, let's just wait for cohort diagnostics. I think it's a fair.
Yeah, there's a lot of these that are going to be junk that are not used, but we're happy. We've been advocating for the state registries to be inclusive and not be restrictive when you're creating a Parkinson's disease registry because of these issues. So I'd like the inclusive top level, and then we go to condition specific.
Yeah, okay.
But this is cool.
And then we will be able to look at, once we implemented across the databases we implemented on, which of these codes actually manifest on people. So you can have an idea.
Great.
Okay.
Thank you. Great job,
everyone.
sir. Thank you so much for doing this.
Yeah, this is great. Thanks a lot.
Thanks for the collaboration. All right, take care, everyone.
Thank you. Bye-bye.